Hello everyone, welcome back to my channel. My name is Lahari, studying at Sri Venkateshwara College of Engineering from the Department of CSE Data Science. Today we are going to discuss about the subject Introduction to Mechanical Engineering. The topic what we are going to see today is Fundamentals of IC Engine. The content what we are going to see today is first definition of heat engine, second classification of stroke per cycle, third fourth stroke petrol engine, fourth and fourth stroke diesel engine. First, let's look into the definition of heat engine. Heat engine is a machine for converting heat developed by burning fuel into useful work. It is said that heat engine is equipped which generates thermal energy and transforms it into mechanical energy. Heat engine can be broadly classified into categories: external combustion energy and internal combustion energy. External combustion energy. An external combustion energy works by using an external heat source like burning coal. To heat a working fluid like water, as the temperature of the fluid increases, the fluid expands, and this expansion is hardness and used to do work like moving a vehicle. Example: steam engine, steam turbines, closed gas turbines, etc. Internal combustion engine. An internal combustion engine is a heat engine in which the combustion of a fuel occurs with oxidize in a combustion chamber that is in an integral part of the working fluid flow circuit. Example: petrol engine, diesel engine, gas engine, etc. Second, classification of IC engine according to number of strokes per cycle. First, four-stroke engine. In this type of engine, the working cycle is completely in four different strokes. Example: this is the internal combustion engine found in many cars. It operates through four distinct strokes like intake, compression, combustion, and exhaust. This cycle is repeated continuously to generate power and propel the vehicle forward. Second, two-stroke engine. In this type of engine, the working cycle is completed in two different strokes. Example: this is the engine used in many small handled tools like chainsaws, leaf blowers, and lawn mowers. These engines operate on a simple cycle compared to four-stroke engine with just two strokes, compression and exhaust combined. They are known for their lightweight design and high power to weight ratio, making them popular for application where size and weight are important factors. Let's look into the next topic, that is four-stroke petrol engine. The working principle of four-stroke petrol engine is based on the theoretical Otto cycle, that is constant volume cycle. Hence it is also known as Otto cycle engine. In four-stroke engine, piston performs four different strokes to complete all the operations of the working cycle. The four-stroke different strokes are performed as section stroke, compression stroke, exhaustion or power stroke, and exhaust stroke. First, let's look into the section stroke. This stroke starts from the piston is at TDC and about to move towards downward. During this cycle, inlet valve is open and exhaust valve is closed. Due to low pressure created by the downward moving piston, the charge is drawn into the cylinder. At the end of the stroke, the inlet valve is closed. The section stroke is repeated by line represented by line AB on PV diagram as shown in figure. Second, compression stroke. During this stroke, the compression of fresh drawn charge takes place by the return stroke, that is BDC to TDC of piston. During this stroke, both the valves are closed. As the piston moves upward, the air-petrol mixture in the cylinder is compressed adiabatically. The pressure and temperature of the charge increases, and this is shown by the curve BC on the PV diagram. The compression ratio in petrol engine ranges from 7:1 to 11:1. Next, third, power or expansion stroke. At the beginning of the stroke, piston is in TDC, and during the stroke, piston moves from TDC to PDC. During the stroke, both the valves are closed. The combustion of the fuel liberated gases, and these gases start expanding. Due to expansion, the hot gases exert a large force on the piston, and as a result the piston is pushed from TDC to PDC. The power impulse is transmitted down through the piston to the crankshaft through the connecting rod. This causes crankshaft to rotate at high speeds. Thus work is obtained in this stroke, hence this stroke is called as working stroke. Also gas expands and does work on the piston, so this stroke is also called as expansion stroke. The expansion of gases is adiabatic in nature, and this shown by the curve DE on PV diagram. As the piston reaches the BDC and exhaust valves, a part of the burnt gases escape through the exhaust valve out of the cylinder due to their own expansion. Fourth, exhaust stroke. At the beginning of the stroke, piston is in BDC, and during the stroke, the piston moves from BDC to TDC. During this stroke, inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gases out of the cylinder to the atmosphere to the exhaust valve. This is shown by the line EB and BA on the PV diagram. When the piston reaches the TDC, an exhaust valve closes, and this completes the cycle. In the next cycle, the piston which is at TDC moves to BDC, thereby allowing fresh charge to enter the cylinder, and the process continues. Next topic is four-stroke diesel engine. The working principle of four-stroke diesel engine is based on the theoretical diesel cycle. Hence, it is called as diesel cycle engine. The section strokes are section stroke, compression stroke, power stroke, and exhaust stroke. Section stroke. This stroke starts when the piston is at TDC and about to move downwards. During this cycle, inlet valve is open and exhaust valve is closed. During this stroke, the downward movement of piston creates section in the cylinder. As a result, fresh air is drawn into the cylinder through the inlet valve. This piston reaches the BDC. The section stroke completes. The section stroke is repeated by line AB on PV diagram as shown in diagram. Second, compression stroke. At the beginning of the stroke, piston is in BDC, and during the stroke, piston moves from BDC to TDC. During this stroke, both the valves are closed. As the piston moves upward, air in the cylinder is compressed to a high pressure and temperature. The process is adiabatic in nature and shown by the curve BC on the PV diagram. At the end of the stroke, the fuel is sprayed into cylinder by the fuel injector. As the fuel comes in contact with the hot compressed air, it gets ignited and undergoes combustion at the constant pressure. This process is shown by the line CD on PV diagram. The compression ratio in diesel engine ranges from 16:1 to 20:1. Power or expansion stroke. At the beginning of this stroke, piston is in TDC, and during this stroke, piston moves from TDC to PDC. During this stroke, both the valves are closed. The combustion of fuel takes place. The burnt gases expand and exert a large force on the piston. Due to this piston is pushed from TDC to PDC, the power impulse is transmitted down through the piston to the crankshaft through the connecting rod. This causes the crankshaft to rotate at high speeds. Thus, work is obtained in this stroke. The expansion strike of gases is adiabatic in nature, and this is shown by the curve DE on PV diagram. When the piston reaches the BDC, the exhaust valve is open. A part of burnt gases escape through exhaust valve out of the cylinder due to self-expansion. The drop in pressure at constant volume is shown by the line EB on PV diagram. Fourth, exhaust valve. At the beginning of the stroke, piston is in BDC, and during the stroke, piston moves from BDC to TDC. During this stroke, the inlet valve is closed and the exhaust valve is open. As the piston moves upward, it forces the remaining burnt gases out of the cylinder through the exhaust valve. This is shown by the line AB or BA on PV diagram. When the piston reaches the TDC, the exhaust valve closes. This completes the cycle. In the next cycle, the piston, which is at the TDC, moves to BDC, thereby allowing fresh air to enter into the cylinder, and the process continues. Thank you for watching, guys.